You're gonna lose. Questions first to start. You're gonna cover fuel tanks and air fracs. That is not a lie. For this purpose, and because of the question that's in your project, you're gonna have to give me 3 components on the fuel tank. I know there's a lot more. The entire aircraft fuel system can be divided into 2 groups or 2 categories. That's high pressure and low pressure. The low pressure is your fuel tank, boost pump, and filter. The tank holds the fuel. The boost pump provides low pressure fuel to the main pump, high pressure fuel. All right? The filter in between there, between the boost pump and the high pressure pump, is to remove contaminants from the fuel before they get to the high pressure pump. Now, at the high pressure pump, right here.
High pressure pump. Can you see it? Can everybody see it?
High pressure fuel pump.
I can't see it, but he's in the way.
High pressure pump, fuel pump, supplies fuel. It is supplied fuel to my fuel control. But before it gets to my fuel control, it goes into my filter, high pressure filter. Purpose of that high pressure filter is to remove contaminants from the fuel. From the filter to the fuel control. At the fuel control, you have the throttle linkage connection. You have a protractor. Under that protractor, there's numbers. Right now, this throttle, this pointer is set at 0. So no fuel, no metered fuel is being supplied to the system. Anything above 0, you're supplying metered fuel to the system. This is the throttle linkage. This right here, facing outboard, aft of the fuel control, is a drain line. After engine shutdown or fault start, residual fuel will be drained out of the fuel control. That is the drain line. If you look forward looking aft, number 4 strut, counting the 12 strut 1 and count it all the way around, there are holes in the forward end of that strut. Y'all see the little holes?
Yes.
Yeah. See them?
Where are they?
Yeah.
Where are they?
I don't see any holes.
On that, yeah, oh yeah, okay, all right. Got it. Got it.
Oh.
Okay.
You see it?
Those are for ram air. Because at every 1,000 foot that we climb, temperature and pressure of the air change. That is my PT2 area. If you come outside of that, this is my PT2 line. That is air that's going through that line. That comes down and around to the back side, inboard side of the fuel control. At the end of that, there is a governor inside the fuel control. If the pilot requires 100% as he climbs, He's pulling against gravity. He can't make no further adjustments. The governor gives it, and the governor takes it away. So it schedules my fuel without the pilot having to readjust the throttle. As he, you got that. So that's my PT2 air fuel governor inside my fuel control. Now, the one thing that you all have to tell me about is adjusting max and idle power. The only thing that you cannot do is acceleration and deceleration checks. So idle, this has to be about 35% RPM, somewhere around that area. I'm not for sure. As the engine is operating, there's a nut with a stud that has an Allen wrench head, and the nut's about a 3/8 nut. You'll loosen the jam nut, and with the Allen wrench, you'll increase idle. And the increased direction is the adjustments. If you exceed it, you'll back it up and start all over again. That's the adjustment of idle. It's on the aft end of the fuel control at 12 o'clock position on the fuel control. To adjust max, you take this to max, and there is a bolt that hits a stop on the fuel control. See the stop? That bolt, if you increase clockwise, will decrease the pointer. If you turn it counterclockwise, it'll increase the pointer on the protractor. Got it?
Is that set to 95 right now?
So the number on the protractors, those are the degrees?
Those are your degrees, those are your RPMs.
So that would,
That's your
where it's
percentage
set right
of
now, it's
RPM.
at 95 horse or 95,
Same as
like
the Ebert.
83% of power.
Kind of a
That has not an EPR.
I mean, it's the same relationship.
Yeah. If you want to say that, I wouldn't say that. That's kind of confusing. That's your RPM protractor. On that scale, it is percentage of RPM. That's what you're going to adjust idle to. Those are your adjustment. That is your fuel control system. From your fuel control system, right above, off to the angle of about 11 on the fuel control itself, is the meter line. Fuel control sends metered fuel to the system on this meter line. Meter line comes around from the fuel control all the way up to what they call the control line, or what we now call a T-fitting. And a T-fitting in general is one path to two path, or two path into one path. In this case, it's one path to two paths. We have 80 PSI on this metered line. The purpose of my meter line is to carry the metered fuel. We don't only have one. Right after the T-fitting, we have two more metered lines to continue this path. The top one is the main fuel metered line to the P&D valve at 6 o'clock position that's mounted on the diffuser. Both these lines, the 9/16 line, is also mounted on the P&D valve. This line right here is called the P&D actuation line, and that is 85 PSI at this moment. Pressurization or pressurizing and dump valve. We're going to talk about the pressurization or pressurizing part of that dump valve here in a minute. This fuel, as it's headed to the PND simultaneously, this bottom one is going to act on the poppet valve of the drain part of the PND valve.
425.
And it's going to close it at 85 psi and open your primary fuel nozzle and manifold. The fuel that's going here will wind up in that. As soon as your fuel is lit, ignited, your secondaries kick in because the pressure from 85 is going to go to 225 psi. Which this line is going to have 225 in it, and that's going to further push that valve into the closed position, opening your secondary fuel nozzles and manifolds. Now you have light off. Now you're at sustaining speed. Everything is open, everything's operating. We're now at idle. We decide we're gonna fly, so, as we're talking, I forgot that we have a check valve in the system. Right after the control line, we have a check valve. There is no check valve on this line, on the PND actuation line. The way you know this is a check valve would have an arrow somewheres in here to show you that this is a check valve, one way. The purpose of that check valve is, like I said, we're flying along now. We got fuel headed into our combustion chambers. Everything's ignited. We're gonna climb, so we put it to max. As we're climbing, we're changing temperature and pressure, but we're picking up pressure more because that's the PT2, total pressure at station 2. And the governor inside, the fuel control, is gonna give me more fuel or less fuel depending on the situation. Right now, it's gonna give me more fuel. He climbs up, we're at the check valve. He climbs up, he's now leveling out, and he retards the throttle to 65 psi from 65 RPM. From 100 RPM to 65 RPM. What happens, think about it, what happens on this side of the check valve, the ones from the fuel nozzles to the check valve, and what happens from the check valve, from the control to the check valve, when he takes that from 100% RPM and takes it back to 65% RPM? Can you explain that?
Does it control the air pressure?
There's no air pressure.
Well, I mean, does it control, like, I guess the fuel air mixture going through
No,
the check valve?
has nothing to do with that. That's a
Fuel-
check
the
valve.
fuel-
It's
the
nothing but
pressure
fuel.
From the valve to the check valve, it will drop quickly, and to keep from the pressure dropping from the check valve to the burner to the nozzles, it'll close and maintain pressure on them where it won't be a drastic drop.
Yes, sir. Did y'all get that?
Yeah.
That's what a check valve actually does. That's how it works in the system. Do you understand that? Yes, it prevents it from coming back, but it's got to maintain a positive pressure, which eventually is going to equal out because what's happened to the fuel at the nozzles.
But it'll be a slow equalization and not a
Oh.
strong.
Yeah.
All right.
Like wham. you know,
Yeah. Okay.
Which it could flood and flood it out.
What happens to, what type of nozzles do I have? Are they injectors or are they free flow?
Injectors.
They're free flow. So, if I didn't have that check valve and I got a flame and I decrease that power and that control, what do you think's gonna happen?
It'd be-
Your fuel, the flame will travel back in through that nozzle, back in through your system.
And kaboom. It's seeing people. Ouch.
You understand now?
Everything's on.
It's not it's a free flow, it is not an injector. This maintains that